Hello friends, let's continue our series. In the lecture number 14, we will be learning about logistic regression. Let's begin. What is logistic regression? Logistic regression is a supervised learning algorithm used for classification tasks, not regression, despite its name, right? So it is just used for classification. It is not used for like it's not like it's not used for regression. Okay? It's just for classification and you will know very soon why. It predicts the probability that an input belongs to a particular class, usually binary like 0 or 1, yes or no, spam or not spam, right? Like binary classes where binary can be either 0 or 1, you know. Instead of fitting a straight line, it fits an S-shaped curve, which is sigmoid function that outputs values between 0 and 1. These values are then converted into class labels based on a threshold, which is commonly 0.5. Some of the features: it is used for binary or multi-class classification. It outputs probabilities between 0 and 1, which is the binary function or the binary digits 0 and 1. It uses the sigmoid function to map predictions. It is based on the concept of log odds and likelihood estimation, right? You might be familiar with likelihood estimation, or basically just probable guessing or probable calculating. So when to use logistic regression? Logistic regression is widely used when the target variable is categorical. It is simple, efficient, and interpretable, especially for binary classification problems. It works well with linearly separable classes, but can struggle when the data is not early separable, not clearly separable, or contains complex problems, right? So basically, logistic regression is used when you have the target variable in a categorized form, right? It already belongs to a category that might be yes or no, a category that might be true or false, a category that might be spam or not spam, and so on. This makes it simple, efficient, and interpretable, especially for binary classification problems, the one that require a yes and no answer. You know, for example, if if a computer is a machine, right? If a computer is a machine and a laptop is a machine, does that mean a computer is a laptop? Without going into the deep logic behind this question, the computer is not equal to laptop, because a computer is a computer and a laptop is a laptop at the end of the day. And in order to answer with a no, we can use like a 0 for false and 1 for true, or no for false and yes for true, or not spam for true and spam for false. Alright, so that's how it works. Now we see some of the limitations are: it is not suitable for non-linear or complex relationships, as we already saw before in regards to the previous regression algorithm, which was linear regression. Then we see that it assumes independent input features, right? Whatever the features that are existing, it will automatically assume them. Finally, the performance drops with highly imbalanced datasets without pre-processing. So if you're having a dataset and you are not using the pre-processing on this data set, and the data set is also highly imbalanced. This will drop down the performance of our algorithm. So that is one of the limitation that you have to remember. Alright. Well, that was it for this video. I hope you were able to understand. In case you have any doubts, you can let me know. Thank you for watching.